Numerical series 11. An amount of 100 kilowatt of heat is transferred through a wall in steady state. One side of the wall is maintained at 127 degrees Celsius and the other side at 27 degrees Celsius. The entropy generated in watt per Kelvin due to the heat transfer through the wall is dash. So before we solve the given numerical, let's understand the statement of the numerical as per the data given. So in this question, it is mentioned that the heat transfer takes place through a wall. So let's draw a wall. So according to the question, an amount of 100 kilowatt of heat is transferred through a wall in steady state. It means the heat enters to the system from this side and leaves the system from this side. So the system here, it is considered to be a wall. So what amount of heat is transferred from one side of the wall to the another side of the wall? So that is Q equal to 100 kilowatt. So this is same for both the side of the wall, Q equal to 100 kilowatt. So one side of the wall is maintained at 127 degrees Celsius. So let's say the temperature at this side is T1, that is equal to 127 degrees Celsius. And if you convert this into Kelvin, so that is 400 Kelvin. So for the next side or the other side of the wall is having temperature T2, that is equal to 27 degrees Celsius, and that is equal to 300 Kelvin. So let's write down all the data here. So data given are Q equal to 100 kilowatt, temperature T1 that is equal to 400 Kelvin, and T2 is equal to 300 Kelvin. Now see, in this question we need to calculate the entropy generated. So the entropy generated, so that is S subscript GEN, S generated. So this we have to calculate. But see, in this question it is asking that calculate the entropy generated due to the heat transfer through the wall in watt per Kelvin. So watt per Kelvin, it means watt per Kelvin, it means here we can say that this watt is what? That is joule per second. So if it is joule per second, it means we have to calculate the entropy generation with respect to time. So for that we consider here the rate of entropy generation as S dot generation. So this we have to calculate for this question. Now let's approach towards the solution of the given numerical. For that, first we have to consider the entropy balance equation. So entropy balance equation. So according to the entropy balance equation, it is total entropy change due to the heat transfer through the wall must be equal to the entropy transfer through the wall plus entropy generated through the wall. So if we write down the mathematical expression of the entropy balance equation, it becomes del S is equal to S transfer plus S generated. Now see, we have to write down the entropy balance expression in rate form. So it means with respect to time. So if we consider the above expression as rate form or with respect to time, so it becomes del S dot equal to S dot transfer plus S dot generation. So this dot represents with respect to time. So here in this question it is mentioned that the heat is transferred through a wall in steady state. So in steady state it means the change in entropy is considered to be zero as the system remains relatively stable without significant changes in its disorder or randomness. So further we write down the above expression as 0 equal to dq by t. So this we have written here as S dot transfer is nothing but it is due to the external heat interaction plus S dot generation. And let's say this limit from 1 to 2. So this can be further written as 0 equal to, so see here, this integration of dq by t can be viewed as sum of all differential amount of heat transfer divided by temperature at the boundary. So this can be written as summation of q dot by t plus s dot generation. So as in this expression, this is written as summation of q, it means we have to consider it as q by T1. So this q by T1 is written for one side of the wall having temperature T1 equal to 127 degrees Celsius minus q by T2. So this we consider for another side of the wall having temperature 27 degrees Celsius. So here we consider minus q because from this side of the wall the heat is leaving the system. That's why here we consider minus plus S dot generation. Now let's substitute all the magnitude here. So 0 equal to q is given as 100 by T1, that is 400, minus again Q, that is 100 by T2, that is 300, plus S dot generation. So if you solve this expression, you get S dot generation as 1 by 12 kilowatt per Kelvin. But in the question, it is mentioned that calculate the entropy generated due to heat transfer through the wall in watt per Kelvin. So let's convert the unit kilowatt per Kelvin into watt per Kelvin. So S dot generation is equal to 1 by 12, that is equal to, so 1 kilowatt per Kelvin, so it is 1000 by 12 watt per Kelvin. So if you solve the expression, so it becomes S dot generation equal to 83.33 watt per Kelvin. So this is the final answer for the given numerical. I think the concept of entropy generation for the given numerical is clear. Thanks for watching. See you in the next video.